In this video, we are going to discuss more in detail about the JVM. In the earlier video, we discussed about Jre. JVM is also a component that resides inside the Jre itself. So Java runtime environment put together contains JVM also. It's a platform to run your bytecode. So we have a visual understanding of how this JVM functions, okay, and also ensure that how this JVM can make it platform independent, means how it makes the Java technology to be called as a platform independent technology. But JVM by itself is not a platform independent. Anyways, let's get into the workflow. So let's assume that you need to recall the earlier learning that we had in the previous video. Okay, that's the Jre. We gave the dot class to the Jre. Jre loads the dot class and hands it over to the bytecode verifier. The bytecode verifier verifies for the originality of the bytecode. Now, in continuation with that, you assume that the dot class is now in the hands of a bytecode verifier, and this person dot class, the bytecode or the bytecode file or the bytecode itself, is going to be handed over to the JVM from the bytecode verifier. So that's how we need to assume it right now for understanding this JVM. Now, when the bytecode verifier is going to hand over the bytecode to the JVM, so let's say I have Windows JVM right now. The Windows JVM will produce another format of code called mission code out of this bytecode. So once the bytecode is verified by the bytecode verifier, it's getting handed over to the JVM. So right now it's Windows JVM, meaning is I'm executing that bytecode inside the Windows operating system. But if you look at another operating system like Linux, we have a Linux JVM for it, and that JVM will take the bytecode provided by the bytecode verifier, and further this JVM is going to interpret that bytecode to that corresponding JVM, to the corresponding operating system, and produces another format of code called mission code respective to that particular operating system. Let's take another operating system, that's like Mac operating system. For Mac operating system, we have a Mac JVM. Now the same bytecode which was verified by the bytecode verifier, this time it's Mac oriented Jre, okay, and the Jre's bytecode verifier who verified this dot class is going to hand it over to the Mac JVM. This Mac JVM is going to further interpret that bytecode and produce it to that corresponding operating system's mission code as another format. So we have JVM for each and every specific operating system out there in the market. So for Windows, Windows JVM. For Linux, it's Linux JVM. For Mac, it is Mac JVM. Now these JVM's actual workaround is nothing but take the input of the bytecode which was verified by the bytecode verifier, and further it interprets that bytecode, and the bytecode is going to be interpreted to another format called the mission code. This mission code is only the code which the operating system can understand, and further, or the machine can understand, and further the mission code is going to get executed in the corresponding operating system. So right now we are going to see that as well. So here we have lined up with list of operating systems. Okay, so one is for Windows, another one is for Linux, another one is for Mac operating system. Now what this JVM is going to do is, the JVM is going to push that mission code which got generated out of it to that respective operating system, and it executes that in the operating system. Then the JVM Linux, the Linux JVM is going to push the mission code that it generated to the Linux operating system, and the same way it executes out there. Now coming to the Mac operating system, you have a Mac JVM who generated the mission code out of the bytecode that was provided, and that's going to be pushed into the Mac operating system, and the JVM is going to make sure that the mission code is getting executed in the Mac operating system. So what's the conclusion on this particular workflow is your bytecode, which was verified by the bytecode verifier, will be handed over to the JVM, and the JVM will further interpret that bytecode to the mission readable format, that's the mission code, and it goes straight into that particular operating system and gets executed. Now, since we have JVM for every independent operating system, but make sure that the bytecode what was generated can be interpreted by the JVM, and make sure that the same bytecode can be executed for the respective operating system. So now when you look at the source code, the .java, which the human have generated it, it's a human readable format. Now we compiled it. Okay, we actually compiled the .class in one particular operating system, but the same .class can be executed in another operating system. How is it possible? It's possible with the help of a JVM. So you compiled in Windows, but still you can make sure that the same .class can be executed in Linux, because the JVM's understandable format is what is .class. So you have an interpreter, right, in middle of your compilation and execution process. You have an intermediator who is nothing but the JVM. The JVM acts as an intermediator, so he is the one who is responsible for making sure that the Java will be called as a platform independent, and also helping us to give a statement called write once, run anywhere. So when you generate a .class out of a Windows, you can still run them on Linux, because in Linux you have a Linux based JVM who can understand the .class that was generated out of Windows, and that .class is going to be further interpreted by that Linux JVM and make sure it generates a mission code for that respective Linux operating system and executes that mission code. And with that, we can clearly understand that Java is platform independent technology, and they achieve this with the help of this complete tightened process called Jre and Jvm. So Jre on a whole provides a runtime platform which involves with multiple steps like class loader, bytecode verifier, handing over the bytecode to the JVM. So a lot of process it has, and the JVM who owns the bytecode will further interpret that bytecode and produce it to a mission code and hands it over to the corresponding operating system. Now that's the reason we call Java technology as a interpreted technology, or Java language as an interpreted language. It's not just a compiled language, it is compiled and further it is getting interpreted. So you will never call Java as a compiled language alone, you will call Java as an interpreted language. But that's not the case like in C and C++. They are compiled language, but Java is an interpreted language. The reason we call it as an interpreted, because it generates an intermediate file format called .class, the bytecode. The bytecode is the one which need to be interpreted by the JVM, and the JVM will further produce it to a mission code and executes in the corresponding operating system. So JVM is platform dependent. Jre is platform dependent, because you have to get the Jre and JVM for the corresponding operating system where you're going to run the bytecode. But on a nutshell, it makes the Java technology to be called as a platform independent. Write once, run anywhere. So in the next video, I'm going to show a practical code of how this JVM does its job. Okay. So thank you so much for your time. I'll catch up in the next video. Bye.